Synergetics Livestream 2.0, January 14th, 2021. I'm Daniel Friedman, and I'm just looking forward to this live stream. Today in Synergetics Livestream 2.0, the spirit for today is clarity, energy, and participation. Clarity, it would be great to get clarity on some of these issues that Bucky is talking about, and also in a time of uncertainty, certainty can be something to strive for. Energy, because these kinds of live streams and learning about synergetics in general should be something that brings energy, not drains energy. And participatory, because of course, synergetics and other kinds of learnings are just based upon participation. Today in 2.0, we are going to go over those key memes and themes and also look at a few new ones that were added last week. Then we'll look at the things to integrate slide and then head to the text. And in the text, we're going to be looking at three main topics. The three sections and the three topics are going to be acceleration, subatomic particles, and systematic enclosure. And so these three topics, just like last week, will be an attempt to capture a little bit of the diversity of synergetics while also just jumping in, because there's so many places that one can start in synergetics, and many sections perhaps are easier to approach at first. Other ones you might want to have a piece of paper or a sculpture or a programming language at hand. So these are sections that are good for just talking about qualitatively. Key memes and themes. So to just read through and not discuss the key memes and themes from the last time, synergetics is very related to relational and multi-scale thinking. Synergetics is connected to our accessible experiences. In synergetics, there's no infinitesimal, nor are there existing points or lines or planes. Synergetics sees design as an anticipatory or cybernetic science. And we can think about the relationship between Synergetics and synergetics being like the relationship between engineering and physics. So kind of like the relationship between the building and the practice and the theory and the abstraction. Synergetics shows us that space has a shape, and that the shape it has is quite specific and quite beautiful. That structure has a pattern, and that these integrities, these pattern integrities, can be static or they can be dynamic, in that they can either resist changes statically or through time they can regenerate or replicate themselves. The idea of 4D is something that comes up all the time with Bucky, and it has many different references, which we're going to try to compile a little bit here, but tetrahedrons being a basis of synergetics is essential. So 4D can refer to the four sides of a tetrahedron, and that comes along with an emphasis on a 60-degree angle rather than a 90-degree angle, as in the right angle world. And there's other uses of 4D, for example, related to bringing perspective into the picture. One thing that was extracted from Synergetic Stream 1.0 is that there's a distinction between universe and system. So universe is the total scenario, whereas system means any subsystem. And system has a shape. Minimally, it turns out that that shape is tetrahedral. So those were the kinds of things that we talked about last week, and now we can go to things to integrate. In things to integrate, one piece we pasted out was 201, experientially founded mathematics, and perhaps today we'll be approaching some experiential mathematics, but we'll head for that journey another day. Today we are going to be looking at acceleration, subatomic particles, and systemic enclosure. And as with last time, though the format could evolve here, the approach is going to be to read the text verbatim without interruption, then read it with a bit of contextualization, provide an example, and then see if there are any questions. And if anyone watching on YouTube live has any comments or questions, they can put it in the live chat. If people are watching these videos later, then feel free to leave a comment. But let's go right to acceleration in section 1009.50 on slides 1220. We'll get back to models and divinity another time, but there's a lot of cool stuff here. Acceleration. 1009.50. Acceleration. Physics does not speak of motion, it speaks of acceleration. And physics has identified only two kinds of acceleration, linear and angular. We are informed experientially that this is a misinterpretation of data. So physics does not speak of motion. So in other words, motion is a story, and what physics is actually characterizing is this idea of acceleration, because motion is being phrased as if there was something called immotion, non-motion, fixedness. And instead of thinking about a fixed point that either is or isn't moving, we can think about objects in relationship to frames of reference that have acceleration, which is change in something through time. Physics has identified only two kinds of acceleration, linear and angular. I'd leave it to the normal physicist to say whether that's true or not. For my physics courses, that sounds like how it was taught. Either the change in the object speed is coming in a straight line, like with an engine powering wheels, or it's involving a turn. We are informed experientially that this is a misinterpretation of the data. So this is related to experiential mathematics, because Bucky is saying, actually, our experience is that there are not two kinds of acceleration, linear and angular. So what is an example of this? The two kinds of acceleration, perhaps an example could be a car accelerating on the gas pedal, that's linear, whereas angular acceleration might be a person on a carousel or on a spinning object is experiencing an angular acceleration because their vector of heading is changing through time, so there is acceleration happening, even if their net speed, their miles per hour, isn't changing around the wheel. It's this continual angular acceleration. And a question I would have are, do physicists believe that there are other kinds of acceleration, and what are those? 1009.51. There are indeed two kinds of acceleration, but they are both angular. All accelerations are angular and cyclically complete. There are no open endings in universe. Physics has discovered only waves, no straight lines. So this is quite interesting. There are indeed two kinds of acceleration, so Bucky goes with everyone that far, but they are both angular. So he's rejecting the existence of linear acceleration, just like he rejects the existence of so-called lines. And it turns out that those are very, very close ideas. All accelerations are angular and cyclically complete. So all curves, rounded sections, must have a convex and a concave side, at least locally. And at least locally, if one extends a curve, any convexity or concavity has to implicate a possible closure. Now, it doesn't mean that it is going to close in real world, but it means that it implicates energetically a closure. So for example, if there's like a U-turn or a switchback on a trail, on a driving or a hiking path, there is a curvature such that there's an internal and an external side to it, and acceleration occurs during that turn, but that doesn't mean that the circle 360 is made. It just means that it's emulating for that segment of the curve a certain kind of circle. And then it could switch on to a different kind of circle. For example, a tight little curve and then a loose curve going the other direction. There are no open endings in universe. So remember, universe from last time, universe is everything. That's the scenario that's the biggest possible one. That's why it's universe instead of the universe. And then scenarios are setups, and systems are sub-universe. And so there's no open endings in universe because there's nowhere for it to exhaust to. Anywhere where it could offload information, energy, entropy, mass, any of those things would constitute part of universe. So if we start with universe as our starting position, we realize, okay, there can't be an ending in universe. Every action is going to, whatever it sets into motion, or not even to use the word motion, whatever it sets into acceleration, or however it modifies the field of acceleration in higher moments, it has to have this kind of circular closure. Physics has discovered only waves, no straight lines. And so the waves can be at extremely high frequency, so they look like they're straight, but they're ultimately still waves. 1009.52. The angular acceleration, however, manifests a vast variety of radii. The differentiation of physics into linear and angular control occurred when humans involved failed to realize that the diameter of the little circle is always a small arc of a vastly greater circle passing through it. The greater the radius, the slower the total cyclic realization. There are no straight lines or linear infinities. Realization of this is what Einstein spoke of as curved space. So these angular accelerations have a wide range of radii, from small radii from a given perspective, so that's a tight turn, to very vast radii. So that would be something that locally, if you only looked at a little segment, it might look like a straight line, but it's actually not a straight line. It's part of a great arc on a very, very great circle. And again, Bucky, with the psychological explanation for how things are, is suggesting that this bifurcation between an angular mode of acceleration and a linear mode of acceleration, where the curvature is 0, is coming from humans' misunderstanding that actually, instead of there being straight lines which go off into infinity and they're parallel and we can do calculations with them very easily and they never close back on themselves and they only get more distance, instead of linear lines, so we know that lines don't exist, straight lines don't exist, those are abstractions, so only curves exist, which means that there is no stretching out into infinity, especially if we're talking about on our globe. We're talking about great circles that reach back onto themselves. And the larger and larger systems like the Earth and the cosmos are bigger and bigger radii. And so it's harder and harder to see that straight lines in those spaces are actually curved as well. He then says realization of this is what Einstein spoke of as curved space. See section 522.21, and we'll pop over there if it loads. And here we go. This is where Einstein reinvoked the elliptical geometry of the mathematician Riemann and instituted the present concept of geodesic lines, which we may describe experimentally as the most economic relationships between two event foci. So on a sheet of graph paper, the straightest line is given by the hypotenuse of that triangle on graph paper. And it turns out that in this curved world that Bucky's suggesting we live in, remember, no straight lines means curved world, the geodesic is the most efficient path, and the geodesic's curvature is described by Riemannian geometry, Einstein, relativity, all these kinds of things. Point 53. Einstein was up against trying to communicate with the mathematicians in terms of their adopted mathematicals, all of which were and still are straight line, XYZ models on a linear frame with linear coordinates going outward from the model to infinity. So field was always a little set of local perpendicular crossings of straight lines, each outward bound to an infinity of infinities. Quite interesting. So Einstein, being taken as a gestalt for quantum or holistic or relational impulses in physics, in contradistinction to reductionist, essentialist, linear, Newtonian, Cartesian perspectives, Einstein was trying to communicate using the tool of math, the technology, and the shared culture of math, using mathematical models, which were and still are straight line XYZ on a linear frame with linear coordinates, going outwards from the model to infinity. So that would be like a point charge of an electron, and then there's some decay function. So you could say, okay, 10 miles away from the electron, it doesn't really matter, does it? But technically, you could say, well, there's non-zero influence of every electron in the universe on every other electron. It might get vanishingly small with respect to the other forces, and people might say that these vanishingly small influences don't matter or they get averaged out. However, we know from the double pendulum, from complexity, from chaotic systems, that actually small changes can have incredible effects on systems, nonlinear effects, cascading effects. So it's not so simple to say that just because it's a small effect, it doesn't matter. And certainly when we have these straight line XYZ out to infinity models, we do have this problem that there's no clean place to say when to stop modeling, and the straight lines do head out into infinity. And that leads to this idea of field being like a local set of perpendicular crossings of straight lines, each outward bound to an infinity of infinities. So this makes me think of a landscape. You could take the north-south derivative. So you could take a ruler that's pointing north-south and just lay it on the hill and say, with respect to north and south, delta north, dx, what is the north-south angle locally? And then you could have the east-west local derivative, partial derivative. And so in the 3 dimensions, you have the height, z, and then you have the local derivatives in the north-south and the east-west directions. And so the field, the electric field, the electromagnetic field, in the regular physicals understanding is being understood to be these local perpendicular crossings of straight lines that are each heading into infinity. And we are now heading into a different way of understanding this so understood field. So an example of this, the point charge, the electromagnetic field, questions I would have I'm always just curious, how do non-synergetics physicists of all kinds and other fields think about these types of claims? 54. All the experimentally harvested information says that the field must now be recognized as a complex of never straight lines that at their simplest always will be very short arcs of very great circular orbits. And the orbits are all elliptical due to the fact that unity is plural and at minimum 2. There will always be at least one other critical proximity imposing aberration restraint focus. Okay. All the experimental harvest information. So Bucky's saying everything I've ever understood, all the stimuli I've ever gotten have been consistent with this Bayesian generative model that I'm about to tell you. So if you have some evidence I don't know about, if you have some harvested evidence that says that this field doesn't have to be a way I'm about to tell you, let me know. But he says that the field must now be recognized, aka he wants people to recognize as a complex system of never straight lines. Those don't exist, so that's obvious. That at their simplest will always be very short arcs of very great circular orbits. So he's saying a few things. First, that it's going to be a network. So think about a social network, nodes and edges. And then these edges, even if they're short or whether they're long, even if they look straight locally, remember that they're always going to be curved. And so even the very, very asymptotically straight lines are actually just increasingly small parts of increasingly large circles. It turns out that these circles, so circle being the shape where all the points are equidistant from a center point. So that's the symmetry condition. The orbits are all elliptical as opposed to circular perfectly due to the fact that unity is plural and at minimum 2. So there's a few interesting things happening here. The first is that an ellipse is ellipse is given by a foci. The circle has a single focus point. That's the center. There's no other side points. A ellipsis is defined by having 2 focal points. It's kind of like the 2 points, and then the ellipsis is drawn around those 2 points. And you don't need a third point to specify the ellipsis, and you can't do it with just 1 point. And so because of Bucky's belief that unity is something that means at least 2 pieces working together in an integrated fashion, if not 2, then 4, then we're never going to have a circular path because that would imply something with only a sole focus. But rather, paths will minimally be elliptical, and potentially have an even more convoluted path. But imagine decomposing like a leaf on a river, decomposing each of those little bobs and weaves into a large or small great circle, and seeing that great circle as suggestive of generative processes in nature. So what a cool way of thinking about it. A single ellipse is a wave system with 2 diametric peak phases, a gear with only 2 teeth at 180 degrees from each other. All other gears are multi-tooth high-frequency waves. All is wavy linear. So a single ellipse is a wave system with 2 diametric peak phases. So what could that possibly mean? It makes me think of an ellipse on a graph and cranking a cycle through the ellipse, and there's kind of 2 peak phases to it, like the winter solstice and the summer solstice. So that's sort of the 2 edges of that ellipse spatially for the Earth referenced to the sun. That is like a gear with 2 teeth at 180 degrees from each other. So this 180 degrees could mean various things. We're going to look at an image in a second, but that's one where the gears are intermeshed. All other gears are multi-toothed high-frequency waves. And so he's getting at this idea with interacting circles through an appeal to a gear and interacting gears. And so it's kind of like around a gear, it's like a sine wave or some other kind of wave around the gear. And so just like a wave can be considered driving a system, a mechanical system, or an abstract system, We could also think about the wave as a physical gear, kind of turning something. A single ellipse is a wave system. Okay, 109.56. Critical proximity crimping in is realized by local wave coil spring contractions of the little system's diameter by the big system, but the local radius is always a wavy-linear short section arc of a greater system passing through it in pure generalized eternal principles. 541.04. Invalid link, so I guess they don't all work. And we'll look at the picture in a second. So critical proximity crimping in. So the critical proximity, close enough to do damage. Crimping in, locking in, stigmergic tightening, making it happen, is realized by local wave coil spring, so push-pull, oscillatory field dynamics, contractions of the little system's diameter by the big system. So we have two nested systems. All of this is nested within universe, of course. Two nested systems. So we got the solar system and Earth, or we have the Earth moon and the Earth, or we have, the Earth and one other subsystem on Earth. The little system's diameter is getting resonatedly constrained by the bigger system. So that's this critical proximity crimping in, or stabilization, resonance, harmony modes, is realized by the local contractions of the little system's diameter by the big system. So that's kind of like the Earth is making these, is like on a spring getting rotated around the sun. Again, just to think of, you could have a different cosmology, that's fine. And then it's getting, the diameter of the smaller thing is getting constrained from these slower, larger, big system modes. The local radius is always a wavy-linear, aren't they all? Short section arc of a greater system passing through it in pure generalized eternal principle. So Synergetics by Hakan, Hakan, 1983. What's interesting is that it uses the same word, synergetics, as Bucky. I really don't know if there's a formal relationship there. I believe this is one of the points where there is a piece of contact. So in Hakan's synergetics, you have these slower level ordering parameters that shift more slowly, like awake versus asleep, and then you have faster, lower level parameters that update and change a lot more rapidly. And so the entraining or the organizing principles are slower. So here, Bucky's saying, okay, got it. Everything's great circles. It's all curves all the way down. All nested systems all the way down. And that the local system, the tighter one, is always a short section arc of a greater system that is part of a larger piece. So whether you're looking at the arc as part of a larger fulcrum or a nesting of systems with a small inside of a larger curve, in both cases, it's like the idea being related to pure generalized eternal principles. So it's kind of like species and genus. That's specific and general. So it's what's specific and what's general. And those are things we can always ask. 109.57. An apparent straight line is not only locally wavy-linear, but a short section arc of a greater system passing through a lesser systems. Check out the figures. Universe lines return upon themselves. So universe lines return on themselves is taking us back to the earlier quotations about how even straight lines are part of great arcs. Ergo, if you were to continue them, they would close back on themselves. And then it's again rephrasing this point that the smaller arcs are just arcs of a larger system. So let's look at these two images. All right, here is one. Let's make this bigger. 1009.57a. Critical proximity crimping in of local wave coil spring. Consideration of the little system by the big system. Prue. Local radius is always a wavy-linear short section arc of a great system in pure principle. So it's almost like if you are going to do a right turn and it's a curve and you're exiting a freeway and you're just going to do a quarter turn of a right turn that has a certain radius. That specific turn is part of a turning back upon itself in pure principle. So in principle, you could keep your steering wheel at that, 1/4 turn angle and then just keep on going in a circle. And so every single curve, every turn And remember, that's everything because there's no straight lines. So every turn, everything is an expression of a deeper principle of that. So no need to get too metaphysical or even wonder if everything is a representation of, for example, the value or the meaning of something. Just like think of it from an angular acceleration point of view. Every time there's some sort of an angular acceleration, it's happening on some curve, on some geodesic. Ergo, the pure generalizable principle reflects some broader system. So we can think about that specific turn, that 1/4 turn, as being crimped in, like a pie tin, I guess, to the general principle. And I'm going to try to read his handwriting. It says, remote mass interattractive induced, critical proximity crimping in. So that's gravitational, quote, quote. Who knows what gravity is? Crimping in, so sun and earth, of local wave coil spring, contracting of the little system by the big system, but local radius is always a wavy linear short section arc of a greater system in pure eternal principle. And this is like showing a fractal zooming in. So here it looks straight on the left side here, and the straighter it gets, the bigger and bigger the circle gets. So the more you zoom in and the straighter it looks when you zoom in, that's actually reflective of an even grander story arc. Now, we can imagine this circle. And it turns out that when you look at it, it is actually wavilinear. And when you zoom in another level, it's wavilinear yet again. So it's a fractal, multi-scale, complex system where there are no straight lines. But it's being done in an orderly way. So it's fake news to say that you're going to either have XYZ linear order or chaos complexity disorder. No, those are two orthogonal axes. We can have order or disorder, and we can have synergetics or Newtonian mechanics. I prefer order and synergetics. C'est la vie. 1223 slide. So here's figure 1009-57b. Make that font a little bigger. Orbit passing, big orbit passing through little orbit. What was called linear acceleration is an unrecognized arc of a bigger system. Wow, how prescient and how important of a point. What was called linear acceleration is a big orbit passing through a little orbit. So let's think about an example. How about a so-called shooting star or any type of space debris falling down to Earth? And so hopefully everybody has been able to look up into the skies at night and see a straight line crossing through the apparently straight line, looks like it's cutting through the atmosphere. Well, that is actually not a straight line, can't be a straight line for a few reasons. It has to be a curve. But the curve that it's on, because it's moving with such inertia, the curve that it's on is very big. So here's the little orbit. This could be us moving around the sun on the Earth. And then once every however many years, it will look like something crosses straight across our path. But it's not actually straight across our path. It's actually on a great circle. Another example I'm just imagining is a car driving down a road, and it's part of an orbit. It's going to go home and then to the grocery store and then back home. And then a cat crosses the road right in front of the car. And it looks like the cat went straight across. But actually the cat is also going on a circle. And so even when it's like the car's on a straight road, I'm driving from A to B, and the cat crossed the road, actually it's part of a bigger picture about different interacting circles and their orbits. So again, there are no straight lines. And Bucky's work is so amazing for these reasons because he'll get to the conclusion there are no straight lines. So he'll convince himself for one reason or another and think, okay, there can't be straight lines because they don't exist. So you keep on zooming in and it's bigger and bigger. And then he'll take that topic to the extreme level by actually following through, actually making good on the kinds of claims if he says, don't use this word, foundation is not a good word to use because it implies that the bottom of something is where it's strongest. Or don't use the word sunrise and sunset because that implies a static Earth. And really we should use Earth clips. Or don't talk about going upstairs or downstairs, talk about going out or in. So these kinds of vocabulary shifts really were something that he took seriously. And just seeing how these kinds of art and science works were produced downstream of clarity of thought is inspiring. And so I hope that these are something that we can all continue to deepen in our understanding to. And then also all kinds of perspectives today, all kinds of people making relics and making artifacts that are like this to help future sense makers on their journey. Let's go to the second topic today, which is subatomic particles, section 935.23 on slide 870. So, make the font a little bigger. So I thought this would be fun to talk about subatomic particles because many people have learned about them in chemistry course, but Bucky is going to take it in a little bit of a different direction. And so it's always fun just to, again, hear his take, and then just whatever our take is, sit with that and develop. 935.23. The names of the players, the positions they play, and the identifying letters they wear on the 3 vector teams of Proton and Neutron, respectively, are identified as follows. The Proton's 3 vector team consists of the action vector, played by the captain, Proton, wearing the letters BD. The reaction vector, played by the electron, wearing the letters AD. And the resultant vector, played by the antineutrino, wearing the letters BC. I'll show us a figure in a second. The neutron's 3 vector team consists of the action vector, played by its captain, the neutron, wearing the letters AC. The reaction vector, played by the positron, wearing the letters CD. And the resultant vector, played by the neutrino, wearing the letters AB. And on first base, we got the neutrino. So here is an image, and this is quite an extended and elaborate metaphor or model, but it's something that is quite encoded, very imbued with Synergetics insight. So I hope that we can get somewhere useful with it. Here are 4 points on a tetrahedra, A, B, C, D. So there's so much to say on this. One thing is that ever since the Feynman diagram, physics has recognized that there are happenings, not things. Like events occur, but things aren't. That's essentialist. The relationist perspective, the relational insight, is that events occur and that things are in relationship. So in other words, instead of defining the nodes and then the edges are the relationships between nodes. So, okay, the node is the person and the edge is the phone call or the social media connection. Now it's almost like we're going to define the edge as the relationship as the actual object. And so the object, in a sense, is relational. That's still framing it in an object-oriented paradigm instead of a truly relational linguistics. But that's where we're headed, is physics is realizing that events occur, but things aren't just there. It's all about measurements and about perturbations. And also that's an insight that we've gotten from other fields. So we have this tetrahedra. Minimal system is 4, and tetrahedra is the minimal system. And so we're going to define these 6 particles. Now, I've put up on this image on the right side 2 more normal ways that people might have heard or seen about these subatomic particles. I'll leave it up to the viewer/listener to decide what this is. Is it a metaphor? Is it a chemistry lesson by Bucky? Who really knows? So we have all 6 of these things that he's mentioned, and those are mapped onto the 6 edges of the tetrahedra. So the minimal system is 4 nodes. Anything less than 4, you don't have a space enclosing thing. You have a plane or a point or a line, and those just don't exist, right? They're metaphysical. They could be conceptualized by the abstraction of human geometry, but they don't actually exist physically. So only space-filling things exist, and tetrahedra is the minimal space filler. So just to kind of reemphasize that, because that's kind of critical. So the tetrahedra has 4 points, which is how we got up to that space-fillingness, but we could also think about, like, actually, you might as well say you can only be real if you fill space, and you can only fill space if you have 6 edges. So instead of this node-centric vertex counting 1, 2, 3, 4, we could actually think about an edge counting 1, 2, 3, 4, 5, 6. And you could get the same place. You know, you lay down 3 edges, you have a triangle. You lay down a 4th edge, and it still isn't enclosing space. You lay down the 5th edge, you lay down the 6th edge, and now you have the space enclosing. So we're going to take a radically relational edge-centric understanding of just everything and map 6 atomic subcomponents or elements to these 6 edges. Then there's 2 teams of 3. This is like as above, so below, yin yang, Jungian shadow, plus minus, everything is the 2 teams playing. And so there's 2 teams that are going to be playing, and he has dictated them as Proton and Neutron. And I think that's kind of fun because it's kind of like the good team and the neutral team. You know, it's not good cop, bad cop. It's good team and massive neutral team per se. And each of these 2 teams of edges are composed of 3 edges and touch all 4 points. So it's almost like we can take that tetrahedra once we've built it, freeze it, and then separate it into these 2 teams. And both of those teams separately could recapitulate the entire tetrahedron because they lock the relationality of the vertices as well. So you could separate out to just this top team, take it away, and then fill in the edges, like fill in AB, which is on the other team, the neutrino, but you could fill in AB. So it's kind of like a hologram because it actually captures the structure of the system. Or DNA helix unwinding, because when you separate these 2 complementary principles, they can still recapitulate each other, but they're different. Now, each of these teams consists of 3 parts, because you had to get there with the Trinity somehow, and it's a Hegelian tripartite relationship. Reaction, action, resultant. Problem, action, solution. 11, 11, 11. And each of these teams consist of 3 different things. So to map them onto these regular particle types, the electron is a negatively charged lighter particle. I'm just going to use like regular vocabulary from chemistry and physics. The electron is a wave particle, not even going to go down that rabbit hole either. But the electron, let's go to this bottom of this image. So the electron is a light and negatively charged particle. That's the reaction that is then acted upon by the proton, which is a massive and positively charged particle. And then there is the resultant is an anti-neutrino, which is a different kind of particle, not one that we hear about as much with the protons, neutrons, and electrons. So what's interesting to me about these 2 teams, and then the reaction, action, resultant, is conceptualized as the positron, the light positive particle, wave particle, the neutron, which is the heavy neutral particle, consisting of quarks, just as protons are, and the neutrino. So it's like these are charged particles that are light. These are heavy particles. Here's a positive charge over here with the positron and the proton. Electron is negative. This is neutral. I can't say whether this is the only way that the Hegelian chemistry synergetic dialectic could be implemented, but this is the one that Bucky provided us with. So a lot of questions. I would love to hear people's thoughts or perspectives on what this means. But Kurt McNamara has done some really awesome research with decomposing systems into these zigzags, into this problem reaction solution, and defining systems in terms of their intercalated zigzags. So pretty interesting stuff. And chemistry, physics, a bunch of other topics will get brought up in other Synergetics chapters, other Synergetics live streams, hopefully some guests. But that's just an interesting take, I think. And yes, I just wanted to look over this part because it makes a nice bridge over to CP Snow, which is something that Kirby Erner has been talking about in some of his recent videos. So let me make the slides bigger. All right. The tetrahedral model of the quantum as the minimum structural system of universe is prime component in producing the conceptual bridge to span the vast chasm identified by C.P. Snow as having for so long existed between the 1% of the world people who are scientists and the 99% of humanity comprehendingly communicated with by the writers in literature and humanities. So, I'll read through then comment. This chasm has inadvertently been RIP my slide position. This chasm has been inadvertently sustained by what, Bucky? What was it? 872. Sorry about that. So CP snow is what we were talking about. This is why we don't want to have multiple tabs open, I guess. It's like human short-term memory, the RAM on my computer, just all the RAM is overloaded. That one doesn't work. That one doesn't work. So CP Snow's chasm is between kind of the scientific and non-scientific worldview. And it is interesting that Bucky describes that 1% of people, so it's not Occupy 1%, it's the 1% of people who are living in a scientific framework. Now, I'd be skeptical it's 1%. I think that's symbolic, just like it is with Occupy. It's symbolic of the fact that it's a select few who are able and lucky enough on Maslow's hierarchy to be able, thanks Chrome, to get us to a place. The 1% of people who are within the science in Bucky's framework are the ones who are basically operating in abundance. And they're the ones who have education and who can anticipatorily plan and have those privileges. And then he's making a metaphor between those who live within the abundance of science and have enough and the inaccessibility of science education is like how humanities and literature are seen as more broadly appealing. So, for example, STEM fields, the science, tech, engineering, mathematics, programming, computer stuff, they're seen as inaccessible, and for it to become more mass appealing, it's often contrasted with things like novels that people read or TV dramas, basically humanities, things that are just, I'm going to have to share this with another browser to get this to work, I think. We'll do it live, though. We'll do it live. So there's a accessibility gap in scientific education. And Bucky, again, is drawing a parallel between the scientific education inaccessibility and the inaccessibility of the fruits of that system, which actually include modern medicine, transportation technology, communications technology, etc. All right, I'm actually going to just, let's see if I can switch over to a better window and then resume this conversation. All right. Let me just resize it. Sorry about that. Sorry. I will have to adjust the filter to just change the cropping, but we'll be on our way in a second. All right. So we were on slide 872, and we were talking about CP Snow and about the techie fuzzy. That's what they called it at Stanford, was the techies versus the fuzzies, and about could the chasm be bridged, but they didn't really talk about CP Snow that much. The chasm has been inadvertently sustained by the use of an exclusively mathematical language of abstract languages on the part of scientists, thus utterly frustrating the comprehension of the scientist's work by the 99% of humanity that does not communicate mathematically. This book, Synergetics, contains the conceptualizing adequate to the chasm bridging task, and it does so in vectorially structured geometry and in exclusively low-order prime numbers in rational whole number accounting. Wow. So Bucky's saying, right, there's this multi-level bridge where because of the language used, again, the actual language and this being taken to mean the kind of systemic barriers to inclusion and participation for the world of science and abundance for everyone, Bucky's saying that on-ramp to education, which is, among other things, impeded by the utilization of mathematical equations rather than aesthetics, experience, all these other pieces that are how we learn other areas, that is what is preventing a world of abundance. And this book, Synergetics, this project, is the kind of bridge meme. He calls it the conceptualizing adequate to this chasm bridging task. So he is mapping the gap. He is bridging the gap conceptually and mimetically, and from a pedagogical perspective, he's bridging that gap. He is throwing himself into the CP Snow chasm. It's kind of like Gandalf in Lord of the Rings. And he's doing this using what? Poems? Kind of. Drawings? Kind of. Math? Yeah. But he's doing it with vectorially structured. So vectorial geometry, just like we've been talking about with synergetics, that's the key thing. And exclusively low order prime numbers. So think 1, 2, 3, 5, 7. Those kinds of numbers, not the big prime numbers, but those actually really do come up, and there's some hilarious stuff later in the book. And it's rational whole number accounting. So if you ever looked at the sine function and just thought, wait, why is the sine of 45 degrees this number? Or why is this number this infinite fraction? I don't really understand. Bucky's saying it's going to be like Legos, because it's going to be about the rational and quantized, so integer-based addition of different kinds of structures. As an instance of chasm spanning between science and the humanities, by conceptually transformative energy quanta accounting, Synergetics conceptually elucidates the Boltzmann import-export entropy-syntropy transaction, paging Scott David, and the elegant manner in which nature accommodates the hidden ball play of now you see it, now you don't energy transference. More beautiful Bucky. So he's going to say, and kind of following how I try to read, reread, give an example, then ask a question, he has read something. And now he's going to ask a question and provide an example. And so here is an example, is the instance. I guess the question is what we read into it, not really his question mark. He doesn't always use those. One of these instances of chasm spanning between science and humanity, so transdisciplinary research, interdisciplinary research, complexity science, is the conceptual usage of the idea of transformative energy quanta accountings within a synergetic framework to generalize beyond the Boltzmann, which means thermodynamic or infothermostatistic, systems of import-export entropy-syntropy transaction. This is like the holographic interface of the Markov blanket. And so he's basically saying, almost foreshadowing decades and decades of research, not all of which has even been carried out yet, foreshadowing that science and the humanities will interface when they can have a thermodynamic-like way to talk about import-export entropy-syntropy and the elegant manner in which nature accommodates the hidden ball play of now you see it, now you don't energy transference. So this is hilarious. Many people might know the game of peekaboo with a young child, where before they have what's called object permanence in their brain, when an object isn't in their immediate visual field, they act as if they don't know it exists. I don't go into claims of what children do or don't know, but that's how they exist. That's how it's been interpreted. So out of sight, out of mind, in other words. Whereas we can have, as adults, things that are out of direct eyesight, but I know my bike is locked up outside. I'll be quite surprised if it's not. And so we have things that are out of sight, but not out of mind. And so Bucky is saying that the same way that a parent might play peekaboo with a child by playing this game of which cup is the ball under, or now you see it, now you don't, nature does that with energy. So it's like, now it's traveling through space and it's invisible, photons. Now it hits a leaf and it becomes radiant. Now it has become tied up in the energy of ATP. Okay, now 2 billion years go by and now it's compressed into some sediment and it's burnt in the context of something else happening. So that's this now you see it, now you don't, with heat, energy, and work. And so Bucky's saying that infothermo synthesis is going to be bridge creating, chasm crossing. So pretty interesting. And yeah, go into different topic in the next section, so we won't go there. Let's go back to our top slide and look at our last topic for today, which is systematic enclosure. So Synergetics section 1023.10 on slide 1262. It's like 1800 slides. So that's pretty cool. All right. So I'm not going to start with 0.2215, which is above. I'll just make the font bigger and then read 1023.10. Systematic enclosure. If we get too semantically incisive, the reader may lose all connection with anything he has ever thought before. That might not be a great loss, but we assume that the reader can cope with their reflexes and make connections between the old words and new concepts with the new and more apt words. For example, since physics has found no continuums, we have had to clear up by what we mean a sphere. It is not a surface. It is an aggregate of events in close proximity. It isn't just full of holes. It doesn't have any continuum in which to have holes. Very nice, Bucky. So if we get to semantically, that means with respect to meaning or language or communication. Incisive, that means sharply cutting. The reader may lose all connection with anything that they have ever thought before. So this is like saying, it's kind of Bucky giving a little window into his mind saying, if I make too many wild words or use too much virtuosity in hypermedia, then I'm going to lose touch with people who are in a different paradigm. And so he's saying that might not be a great loss. So there might not be that much with which to lose contact with, or maybe it's a child. And so there isn't an earlier history of specific types of thoughts. But we assume that the reader can cope with their reflexes and make connections between the old words and new concepts with the new and more apt words. So it's always funny, sometimes when you want to teach someone a new word or a new concept, it's related. And sometimes when you want this new word or new concept to be used, then it's like a struggle to get adoption. It's a struggle to get people to use some term of art or some jargon within some field. But then words that fall into common usage and can even enter the dictionary over just a few years. So just think, it's 2021. We could have some words in the dictionary in a couple years, so to speak. That doesn't mean what it used to mean, but you know what I mean. We could have some words in the common use in one language, some languages, all languages in a couple years. There's things that have been introduced by virtue of the events of the preceding months and years that didn't exist 5 years ago. So language is evolving so rapidly. And Bucky's giving an example, which is that because there's no continuums, he's going to stick true to not just saying, oh, well, there's a continuum, but then there's all these holes in it. He's saying, no, just start with that. Yes, and. It's just a surface. It's a mesh. It has gaps. Instead of it's a continuum that's full of holes, you just say it's a mesh. And instead of having to use caveats, just speak the meaning that's downstream of the deep assumptions. For example, that there's no continuums or no straight lines, no infinitesimals. 1023.12. The word polyhedron has to go because it says many-sided, which implies a continuum. We don't even have the faces. Faces become spaces. They become intervals. They become nothing. The Einsteinian finite universe is an aggregate, non-simultaneous universe, is predicated only on the absolute finiteness of each local energy event package and the logic that an aggregate of finites is in self finite. So this is pretty key. This is no matter how many finite things you add up, you're still going to be talking about finite things. Nothing from nothing equals nothing, but 1 + 1 equals some finite number. It could equal 4, could equal 2, but it's a finite number under these axioms. If somebody has a different axiomatic set, great, let the boys play. He says the word polyhedron has to go because its focus is on the sides. So not that so-called polyhedra don't exist. Not that a triangle isn't real. It's an idea. It's a real idea. But its focus, poly, meaning multiple, and hedron, meaning side, is side-centric. So just like in the network theory perspective, we were focusing on the edges rather than the nodes. That's the relational insight. We're going to have a volumetric insight, maybe that's what we could call it, which is that we want to have volume be our first mover. So instead of saying, well, points are the simplest thing because they're unidimensional, and then points, 2 points make a line, 2 lines make a plane, and then multiple planes combine in some way to make a magical space-filling shape. We're going to start with the idea that space is filled. And space can be filled by a very long, spindly thing that looks like a line from far away. Or space could be filled in a different shape. And the limit case of being space filling with equidistance with respect to an energy event is spherical, roughly. And so Bucky seems like he would want to prefer a word that's more volumetric, like univolume. How about just volume-filling shapes? Strategies on space enclosures. That's kind of what we're talking about here. Systematic enclosure, which is the tetrahedra isn't just cool because it has 4 sides or 6 edges, or 4 points, 4, 6, 4, 1, 2, 3 dimension. It has one volume. That's why it's fundamental. So we can do all this low-level stuff on the point. How many points does this shape have? How many edges does it have? How many sides? How many faces does it have? But all of those don't exist until they're downstream of a volume. And you don't have volume until you have tetrahedron. So that's the key entry point into the system, the tetrahedron and the volume and the systematic enclosure. So instead of define the network, it's like define the space. And yes, defining the space entails relationships and entities, just like the colony entails the nestmate. But it's thinking from the universe first, if you want to. 1023.13. The spheric experience is simply an ultra-high frequency of finite event occurrences in respect to the magnitude of the tuning perceptivity of the observer. High frequency to the human may be low frequency to the mosquito. So it's all relative, and this is kind of being taken in multiple senses. He's saying the sphere is basically the convergence of a volume enclosure with more and more faces, more and more edges, more and more points. And so it's not like we tweak the number of edges and then the number of points changes and the number of faces and the volume changes. It's like we're thinking about the shape that's enclosed and then how coarsely or finely we're approximating it with manifestation of media, which is why when you zoom in, it's always going to be finite because it's physical, not conceptual, metaphysical. It's real. And then using the example, entomological example, might I add, of a mosquito, he's basically saying something that's high frequency to a human might be low frequency to a mosquito. So within the overlap, the shared informational niche, something might be intolerable speech to one person but not another. Or one wavelength might be picked up by one microphone but not another. Or it might sound better in one microphone or have higher fidelity. It's just like, it's always about the observer in relationship to the observation. And that's what defines whether something is relatively high or relatively low on any scale. If we get rid of the word polyhedra, what word do we have in its place? A high-frequency, omnidirectional spheric event system. Polyhedra are finite system enclosures. They are topologically describable finite system enclosures. They are universe dividers. They are not linear dividers, but omnidirectional universe dividers dividing outside from inside, out from in. A mosquito has macro, micro, cosmos system perceptivity at a different level from that of a whale's. Probably each organism's stature constitutes its spontaneous observational level of macro-micro subdividing. Bigger than me, littler than me, within me, without me. Bucky be praised for these classic and interesting writings. So we are going to get rid of the word polyhedra, at least in our heart, at least etymologically, in our understanding of what things are. And we're going to replace it with something like a high-frequency asymptote that's omnidirectional with respect to some spherical event. So lightning strikes, and then you see it and the flash before the sound. So that's like 2 spheres, and it's finite. It's really maybe approximated by a sphere, but ultimately it's about the actual specific waves. Remember, no straight lines, just the waves that came out of that happening, that fracture asymmetry event. Polyhedra are finite system enclosures because polyhedra are always finite. So if you say, imagine an angle or a line and just stretch, it's like you could have an infinite line. That's the whole point. Lines stretch in all directions. Rays are fixed at one point and stretch out to infinity in one direction. And then a line segment is what is just from A to B. So for Bucky, not just is everything part of a great arc that in principle curves back on itself, but everything to exist must be space enclosing, ergo tetrahedral or more, polyhedral, Ergo, a finite system enclosure. Otherwise, what are you talking about? Literally. What about these systems? Well, these systems, whether they're synergetics ideas or tensegrity sculptures, they're topologically describable and finite. They are universe dividers. They're not linear dividers like a support vector, like an SVM, a principal component or something, linear discriminant, but omnidirectional in all directions, universe dividers, dividing outside from inside, out from in, Markov blanket, free energy principle, active inference, internal, external states. A mosquito has macro, micro, cosmos system perceptivity, that's its Umwelt, at a different level from that of the whale. Right, the niche is different, the in is different, the sense is different, and the action is different. It's different systems. Probably each observer organism's stature constitutes its spontaneous observational level of macro-micro subdividing. Bigger than me, littler than me, within me, and without me. And so again, another little active inference tie-in there, which is that you have relational thinking, things that are bigger or littler than things like me. And then you have the division of things that are internal or external states. And I won't read these sections, but it's interesting just how he says, we relinquish the word polyhedra to re-employ our new term, systematic enclosure. So, which can be generalized to serve creatures of any size, i.e. a tetrahedron big enough for a mosquito or big enough for a whale. So that's kind of a fun note to end on because, for a lot of reasons, I guess, it started with this idea that things have to have shape and fill space in the real world to actually exist. You can imagine something that doesn't exist, but for things to actually exist, they have to fill space. And that means it has a shape. And it turns out that space has a shape, and that you can think about it in terms of points, edges, and faces instead of volume. But just like thinking about a book in terms of letters, words, or even sentences, there's something about the integration of a shape, tetrahedra, a novel, a person, a team, a belief. There's something integral where, although it has nested subcomponents or corollary descriptors, actually the primary level of analysis is the whole. And that's where we should start rather than leading up to it as a conclusion. So I remember during my graduate school, sometimes my PhD advisor, Professor Deborah Gordon, she would take a look at what I had written and just said, take your last sentence and put it in the first part. So start with a big part and drill down. So say X is the case, and we know this because ABC, rather than we know B, we know C, and then because of that, X is the case. So in a very different capacity, that was kind of like this system first insight. So this volumetric insight that things don't exist till they have volume, ergo things must have shape and be tetrahedral or bigger, asymptotically converging in a spherical design that, yes, it has lots of points and lots of edges and lots of faces, but what really defines it is the increasing symmetry of its volume enclosure around increasingly close energy events. And it's always going to be at least two energy events because there's no unperturbed mover. That would be a sphere, and that we don't have those. So all of this is just quite interesting stuff. Here's one more little interesting part. The four vertices, I don't know, sometimes these errors are on purpose. The four vertexes plus four faces plus 6 lines of the tetrahedron must become 4 somethings plus 4 nothings plus 6 relationships equals what? 1. So that's what's kind of fun. That's division of labor. And this was a fun little conversation. Let's just return to our top page and close it out. So this was Synergetics Livestream 2. It was a little bit more than an hour. And I hope, although there was that Chrome and human memory overload, with clarity as a principle, I hope we stuck to that. Energy, I feel good. I hope that whether you're listening live or in replay, it was interesting and suggested the kinds of participation that could be in store for you. So if you want to go deeper into any of these ideas just through suggesting or prompting me, or if you want to come on the live stream, or if you want to give a presentation, have a dialogue, raise some issue, give your perspective, that would be awesome. So with that being said, I'll probably look a little bit over this video, find a few more areas to jump into for future Synergetics live streams. But thanks everyone for watching, and good luck with your Synergetics journey. I hope to see you around in the future.